Hey, APE students, this is our first video lesson on the tragedy of the commons, overfishing, and aquaculture. And in introducing this to you, I'm going to try in at least some of my videos this year, you'll see these types of screens up, and I'll try to be conscientious of reminding you what topics we're talking about. I'm really going to try to use the course and exam description frequently. This document is available on our course webpage. It's on one of the menu options on the left-hand side. So do feel encouraged to navigate to it. I recommend you use it as a study guide. If you open it up, you'll find pages that look like the ones on the screen for each topic. And for any topic that we study, so this is going to be about 5.1, 5.8, and 5.16, as you can see on your screen. For those topics, you can scroll forward to the pages that contain the info on those topics. This document is kind of designed for me, but look how useful it is for you because it has the essential knowledge points that you really need to know. So, I'm going to give you extra info. I'm going to try to be interesting and engaging and try to give you lots of cool information to help you to be a really informed citizen, an informed environmental scientist in ways beyond what the College Board necessarily requires. But if you're ever wondering, okay, that was interesting, but what is it that I really, really need to know? Go to that document and here are the things you really, really need to know. So you might make in your notes, if you're taking notes at home, you might make a note of the topics that we're talking about. This time it's these three. Okay, moving forward into 5.1, the tragedy of the commons. I titled this slideshow, The Tragedy of the Commons, because this idea is somewhat problematic, but let's start with the idea itself before we critique it. So Garrett Hardin in 1968 wrote this influential paper about the tragedy of the commons. It's really considered the classic paper that elucidated this idea. And it's actually considered one of the most influential. In fact, one study called this the most influential scientific writing, this paper, the most influential scientific writing of the 20th century, just to give you an idea that this influenced more scientists than any other work because it has economic, ecological, and other implications. So the idea is that the tragedy of the commons involves a shared resource that multiple self-interested parties exploit to the point that it becomes degraded and potentially collapses. By commons, we mean common resource. So in our fish banks simulation, for example, fish are commons. We could also call the ocean a commons, and we could say we degrade it by dumping trash into it, like plastics, right? And creating plastic pollution. So plastic pollution in the ocean could be a tragedy of the commons because multiple self-interested parties are dumping trash into the ocean. The ocean in this case is the commons, and we're degrading it because we're being self-interested and just causing this tragedy. The original example that Hardin used in his paper was of overgrazing. He basically said, if you have a bunch of different people with herds of animals and they're using a field that's held in common to graze those animals, then each herder or each owner of the animals will send their animals out to graze as much as possible, and the commons will become overused, overgrazed, and it will degrade in quality and eventually collapse. Now, I'm not going to lie and say that this is never true, that usually the truth is somewhere in between. This idea is perfect and this idea is completely wrong. This idea is a limited idea in practice. Sometimes this does happen. As you'll see in our fish banks simulation, this is a real threat that it probably will happen. If you've already run the simulation before you're watching this, you'll see it probably has happened. And with a resource like fish that are in the ocean, which is a massive place that is not controlled by any one country. It's an international place. There's no one that lives in the ocean. So it's a hard to monitor place. It's hard to catch people doing things to the ocean. There's a lot of different countries, a lot of different ideas and cultures that have coastline and that might treat the ocean differently. It's hard to have an agreement on how we're all going to treat it. The ocean is a common place to find a tragedy of the commons. The atmosphere is another common place to find one. We might talk about climate change as a tragedy of the commons. Multiple self-interested parties are dumping carbon emissions into the atmosphere, and it touches every country on the planet. So it's very hard to reach an agreement, as you've probably seen, to limit those carbon emissions globally. And so we do see a tragedy of the commons there. Now, that said, I want to tell you a little bit about Elinor Ostrom. And if you know who she is, then kudos. If you don't, you really should. This is somebody who we should know much better than we do. She happens to be the first woman to win the Nobel Prize in economics. And she won that prize in 2009. Sort of embarrassing on economics that it took them that long to have any semblance of gender equity, but that's a different story. Ostrom basically won the prize for work that thoroughly critiqued Hardin's idea and showed that it's actually not very common, get it, to have a tragedy of the commons. In fact, only under certain circumstances, such as the ones I mentioned, do you get a tragedy of the commons. Otherwise, like local management of a resource, like a grazing area you've got different people grazing their animals in, those people are actually, this is a direct quote from her 1999 paper, they make mistakes, they're fallible, but they are boundedly rational. I love that phrase. Within certain boundaries, they make rational decisions. They're not just idiots who are going to collapse the commons all the time, right? And importantly, they have complex behaviors in psychology. We have community norms as people, right? So there are plenty of things you're not going to do because it's against your community norms. If you're in a situation where you're quite sure you can get away with it, or you're pretty sure someone else is going to like do something different, and so there is no real community norm, again, like the ocean, there's no real agreed upon community norm because there's too many different users with too many different norms in their communities, well, then you might get a tragedy. But if otherwise, you might not. You might actually have a group of people who manage to use a resource quite well. And I love this quote from a different paper describing what is referred to there as Ostrom's law, to sort of summarize her idea, that really like people figure out ways to make things work in practice. It doesn't have to be like the theory dictating that it's always going to be a tragedy. In fact, there are all kinds of arrangements that work in practice. We should be figuring out the theory that corresponds to that. And so she has many great quotes that correspond to like fitting theory over what's actually observed. A really worthy individual to know, Eleanor Ostrom. So I'm glad if I'm introducing her to you for the first time that now you know her. Now I'll follow up. At my school, we happen to have a rival high school right down the street where this fellow named Jamie Workman went to school. And he happens to be a friend of a family in our Sacred Heart community and was willing to come and talk to my apes class last year about his experiences in the Kalahari Desert. Now, he went to the Kalahari Desert years ago when he was a young man fresh out of college and really wanted to go and like make a difference in the world. And he heard that there were these indigenous people in the Kalahari who were, because of new government policies, they were having their access to water limited, and he wanted to go help. So he showed up, he told us last spring, he showed up in Africa and rented a Land Cruiser and decided, I'm going to drive out into the Kalahari Desert and I'm going to bring a bunch of water. And so he gets these giant tanks of water, loads them into the truck, and he drives out and his truck breaks down. And he's forced to drink the majority of his water because he's stuck in the desert, right? And he says it's basically a disaster. And he finally gets help and makes his way to the people who he wanted to help in the first place, this indigenous group out in the desert. And when he gets there, he has very little water left. He's very apologetic, says, I'm sorry, but you can take what I have. And they're like, oh, we don't really need the water. We're good on that. We're really good at getting water in the desert. That's why we've survived here for like thousands of years. But we will take the containers. We could use those. That would be nice to have, right? We can put the water that we know how to get into them. And he talks in his book, and he talked in his talk to us about how humbling this was to realize that actually this isn't some like indigenous group living in some kind of like blissful ignorance out in the desert. They are a group with a complex economy. And actually in their economy, water is essentially their currency. They value water really highly. And if you acquire water, you can use that like in trade. You can use that to acquire social status. So they have an economic system that's functional. The thing that I found most influential in his talk is he described like they don't have a tragedy of the commons, even despite this extreme scarcity of this resource, water, in their region, because they've developed an economic system around it and a cultural system around it that's very functional for managing the resource. He followed up by asking us, do you know how much Cal Water, the biggest utility out here in California, where you may not know if you're not here, but I'm sure you've heard, we don't get much rain and we don't have much water. It's quite dry. Well, he asked us, what do you think Cal Water values a gallon at? And the answer is a big fat $0. In fact, when you pay your water bill, all you're paying for is transport of water to your home. That's all you're paying for. The water is $0 because Cal Water doesn't pay anyone for it. They just take it off of the landscape from a reservoir, from a natural body of water. They take the water and they ship it to you. So they charge you for the shipping plus some profit for themselves. What does this mean? This means Cal Water wastes 400 million gallons of water every year to leakage. It simply leaks. Why don't they fix the leaks? Because it would cost money to fix the leaks and the water is valued at $0. So literally the economics are not there. If you're sitting in front of your computer going, that sounds ridiculous, that should not be the way things are. Exactly. Now think about Hardin versus Ostrom. Basically here you've got I would say, foolish economic system that puts a $0 value on water in a place where it's really scarce, California. Now that might be good for providing cheap water, but it's probably not good for long-term sustainability of the resource. Now you're beginning to see what we're doing here in AP Environmental Science. It's not to say that economics is stupid, not at all. Economics is very important, and having good economic systems is very important. And having an economic system that takes into account long-term sustainability of the resource is very, very important. A lot of what we're going to be looking at in this class is how do we integrate and have intelligent economic systems that take into account concerns about long-term sustainability of resources. So I hope that gives you a good introduction to that idea and a good introduction to what we're doing here in the course. Now, two other things I want to point out to you. I've got on this slide, and the slides are posted on our course webpage. I'd like you to actually open up the slide and watch these different videos on destructive fishing methods. This is going to help you when you go to write up your lab on the fish banks exercise, the Tragedy of the Commons lab. You should also take notes on them. They're very short video clips, and they're very good about this is what happens when you do these methods. These are the industrial methods that are destructive: long lining, bottom trawling, purse seining, and using radar and spotter planes and so forth. They have key unintended side effects like creating bycatch, which is catching animals that you're not intending to catch, and then they end up dead and thrown away, which is ridiculous, and it happens. It's actually a huge problem, as you'll hear about in the video clips. And habitat destruction is another byproduct, especially of bottom trawling, as you'll hear, not so much of the others. When you bottom trawl, you drag a net and it destroys a lot of habitat as a consequence. These are unintended side effects, but they are problematic. So watch these videos, know about those side effects, and know about how we are so capable, because we are so technologically advanced, we are so capable of overfishing. This is why commercial, industrial scale fishing methods. Now, finally, I posted this link as well to a short, very interesting clip on sustainable aquaculture. Aquaculture is the fancy word for fish farming in Europe. I'd like you to watch the video and write down as you go which types of features make an aquaculture operation sustainable, which types make it unsustainable. Pause this video, go watch this one, come back to this video. Okay, I hope you've had a chance to pause it and come back to the video. If you haven't, pause the video, come back after you've watched this. You should have seen the sustainable features are: one, it relieves pressure on wild fish. As they point out, if you farm fish to feed people who want fish, you don't have to fish as much, and you can avoid overfishing, hopefully, and you can relieve a little bit of the pressure on wild fish stocks, right? Second thing that can make it sustainable is if the methods being deployed are sustainable. So if the feed that's being given to the fish is sustainably raised or harvested, that makes it a more sustainable operation. If the materials used to construct it are sustainable, that makes it a sustainable operation. If the waste from the fish, which is a problem, is captured by something like that seaweed farming operation, that's much more sustainable. You purify the water and hey, you turn an economic profit. Huzzah, like I'm saying to you. Environmental science is actually not about limiting economics. It's about using economics in a sustainable fashion to do good things for people on the planet. That's what environmental science seeks to maximize and inform, right? Now, what could make a fish farm unsustainable? If fish escape, they can have impacts on wild fish populations by potentially outcompeting them or interbreeding with them and reducing genetic diversity. The waste from a fish farm creates nutrient pollution. We're going to learn a lot more about that later in the course, but it causes all kinds of downstream problems. So nutrient pollution is an issue. They're breeding grounds for disease. You heard about the sea lice. Sea lice are a fish parasite that if you put a bunch of fish into a tight quarters, it's just like humans. If you put us all into a small room, we're going to spread disease that way. Like you definitely learned about that in the last couple of years with COVID, right? That's why we were all at home in our own rooms for a while there. So, you know, putting a bunch of fish together, same deal, except with fish diseases and parasites like sea lice. Those can then, of course, jump out of the fish farms and into natural populations where they can have impacts. Also, if the feed or the other inputs into the fish farm, like materials used to build it, are harvested or raised unsustainably, then that creates issues too. So I hope that's a good summary of the topic. I hope you learned a lot in this video. I hope you got to watch all these video clips. I hope you enjoyed the lab. I hope you're enjoying the class so far. I'll be back with more learning later for you. Thanks, everybody.